So we will take a look at one more hypothesis test here from the top, and this one has to do with cat ownership and schizophrenia. It has to do with toxoplasmosis, which is a disease that cats can pick up, that it runs its course mostly and then they get over it, but the parasite actually doesn't completely vacate the body. And it is possible for a cat to transmit toxoplasmosis to a human, and the parasite also doesn't completely vacate the human body either. There's been some research about this. It actually takes up residence in the brain and it becomes mostly dormant, but there is a lot of research suggesting that it is changing the connections just ever so slightly in our brains and changing how we think and what our personalities are even a little bit. So it's a very interesting topic, and there are two variables in this study. One is mental illness, yes or no, do we have a diagnosed mental illness? And the other is whether we had a cat growing up as a child. So two categorical variables. And I have to emphasize cat in categorical here. Two categorical variables, and those are mental illness or schizophrenia being the primary mental illness, and whether or not they owned a cat as a child. So two categorical variables means that we can look at a difference in proportions, right? From our data, we could have a difference in sample proportions. And for our hypotheses, we're going to be interested in a difference of population proportions. So let's say that everybody actually, no, sorry, let's look at it this way. 136 of the 262 people in the mentally ill group owned a cat, and 220 of the 522 people in the not mentally ill group owned a cat. So both proportions are going to be expressed in terms of whether they owned a cat, right? So this is, the first group is mentally ill, and the proportion is owned a cat. The second group is not mentally ill, and the proportion is owned a cat. So owned a cat is the same in both of these proportions we're going to define, and the real distinction is mentally ill or not. And that's why I'm going to call this P sub M for mentally ill, and this is the proportion of all. This is not just the ones in the study, this is for our whole population, proportion of all mentally ill people who owned a cat. The word owned isn't quite right here, because really the cat owns you, right? So let's say who had a cat as a child. And P sub n is the same proportion for not mentally ill people. So my null hypothesis is that if there's no association between having a cat and having mental illness, then these two proportions should be the same. Pm equals Pn. Remember that your hypotheses are always written in terms of the parameters, not in terms of the statistic. So we never put hats on these P's in our hypotheses. All right, we are asked the question, perform a test of hypothesis to answer the question of whether owning a cat as a child could be related to a greater chance of mental illness later in life. So this is really saying that the proportion of mentally ill people who had a cat would be higher than the proportion of not mentally ill people who had a cat. And if I want to write these as something that resembles a little bit more closely the statistic in the randomization distribution, this first one would be PM minus PN equals 0, and the alternative hypothesis would be PM minus PN is greater than 0. So as long as M is my first group and N is my second group, then I am looking at a right tail test. With proportions, we get to control which is the first group and which is the second, because we usually don't take our data from a data set. We have summary data that we can just type in, so I can actually make sure that it comes out that the mentally ill group is the first. That's why we didn't have to go to StatKey before defining our hypotheses here like we had to with a difference between two means. So in StatKey now, I want a randomization hypothesis test, this time for a difference in two proportions. And I'm going to click on Edit Data and enter my Group 1 count, my Group 1 sample size, my Group 2 count, and my Group 2 sample size. I've decided that the mentally ill is the Group 1. So I've entered the values: 136 out of 262 for Group 1, 220 out of 522 for Group 2. And in StatKey, I can see under Original Sample here, this also gives me the value of my difference in proportions. So we're looking at 0.098 as the difference in proportions. And I will generate a few thousand samples to get started. We did indicate we're doing a right tail test, so I click right tail, and remember that this number here where it says Group 1 minus Group 2 and proportion, this is really my value of P1 hat minus P2 hat. So this is the number that I'm going to use to overwrite the boundary value down here along the horizontal axis. Instead of 0.075, I'll click on that and overwrite it with 0.098. So it looks like I have a p-value here of 0.0045. And the rough sketch I'm going to draw doesn't have to have all of these bars and dots. It's just going to be a very basic shape. Looks like kind of a bell-shaped curve that we have there, and here in the middle is my null parameter of 0, because that is P1 minus P2 equals 0. What defines my tail off here to the edge is my PM hat minus PN hat equals 0.098. And the p-value is the area of this curve, or rather, it's really the proportion of dots that are in this tail in the curve. So that's the p-value that we already wrote over here. Now remember that when we interpret a p-value, this means something very specific. If the null hypothesis is true, the chance of us observing this statistic or something more extreme is equal to this probability. So that's always what we want to say for our interpretation. We don't just say if the null hypothesis is true, we want to say what it means for the null hypothesis to be true. In this case, that would mean that the proportion of mentally ill people who had a cat as a child is equal to the proportion of not mentally ill people who had a cat as a child. And we could also say that in fewer words by saying that there's really no association between having had a cat as a child and having mental illness. So if there's no association between having had a cat as a child and having mental illness as an adult, then the chance of us observing something this extreme or more is 0.0045. All right, so the way I wrote it isn't exactly the same words. I thought it would shorten a little bit if we could just say an association between cat ownership and schizophrenia. So if there's no association between cat ownership and schizophrenia, the chance of observing something this extreme, and technically we're saying this extreme or more, but it's okay if we leave out the or more part. We don't mean exactly precisely this extreme. We just mean at least this extreme is 0.0045, and that is pretty low, right? The chance of us observing something this extreme, if there really is no association, is pretty low. And what that tells us, if we flip that around, is there probably is some association, right? We believe that there is some association. So we have, this is less than 0.01, so we have very strong or overwhelming evidence. I'm going to go with very strong. We have very strong evidence of an association between cat ownership and schizophrenia. And I am inserting the statistical significance in here. The commonly used values of alpha are 0.01, 0.05, and 0.10. This is smaller than the smallest of these, so I'll go ahead and say at the 0.01 level. Okay, so we managed to fit a conclusion in here. We have very strong evidence of an association between cat ownership and schizophrenia. Does this prove that cat ownership causes mental illness? This is a test 1 type question here, really. Causes is really what we want to get our attention in this. We have to look back at the study and recall how it was conducted. We randomly selected 262 registered mentally ill individuals and chose some families without mental illness that were of similar characteristics, and then surveyed whether or not these people had a cat as a child. So this is not a randomized experiment. The explanatory variable cat ownership was certainly not randomly assigned. That would mean we have to actually bring cats to families, right? And say, okay, you are going to grow up with a cat, and then we're going to see if you develop mental illness as a result of it. Lots of reasons why the study was not conducted that way. So we cannot conclude from this study that cat ownership causes mental illness, just that there is some association, which makes sense. I mean, I love cats. And I'm crazy, right? But I don't think that the cats made me crazy. I think that I just love cats partly because I'm a little bit crazy, right? So we have an association here that we haven't explained by the cat ownership necessarily causing the mental illness. Be aware that an answer to a question like this is really looking for something specific in your explanation. It's not a good explanation to say, no, because lots of things contribute to mental illness, or no, because there could be a genetic factor. The idea of causation isn't that having a cat means you're 100% going to get mental illness. What it means is that if you choose to get a cat, it affects your likelihood of getting mental illness, right? And even that level of causality we have not established because the explanatory variable was not randomly assigned. Now, if you're interested in knowing a little bit more about the different kinds of studies that have been done on this, the truth is there has been enough research on this to conclude that there is most likely a causal relationship here. There have been some other studies involving rats that were infected with toxoplasma, and on those studies, at least the explanatory variable is randomly assigned. It's maybe an open question still whether the way rats react to it is similar to the way humans react to it. So there is a fairly strong body of evidence that there is a causal relationship here. But we're only answering in the context of this one study, and in the context of this one study, we would say no.